Hello, health class. Today's our topic is going to be about reflexes. Reflexes are things like getting your knee tapped with a hammer at your pediatrician's office, or someone's coming to hit you in the face and you automatically respond. You smell something good and your mouth salivates. That's a weird word. Something comes flying at your eye and you close your eye, or the lights in the room turn off, and in order to get more light to come into your eyes, your pupils get bigger. So reflexes, the number one thing for reflexes is that they are involuntary. Your body just does it, and it does it incredibly quickly because you're bypassing the brain and just using your spinal cord. They're involuntary reactions, and if you think about it, they're the exact same for every single human being, except for people that have conditioned reactions or reflexes. Like, let's say someone goes to hit you in the face. Some people will automatically just move their head out of the way, or some people will just throw down their karate chop that they learned from martial arts in elementary school. But either way, you are reacting or reflexing to this dangerous or harmful, etc. type of stimulus. So let's see. All we have right now is reflexes, involuntary, and I will write right here, in the beginning, the spinal cord controls the reflex. The brain will get the signal because the brain will have to deal with the pain and the response to the pain, etc. later, but immediately right off the bat, you move your hand off something sharp, you are using your spinal cord only. So we're going to actually sketch this reflex, but what I want to do first is just remind you of some things about the reflex arc. So I'm going to go here. All right, so this is your spinal cord. People say spinal cord, but that's actually really nerve tissue. It's your spinal column, and it's protected by these bones called vertebrae. There's 24 stacked bones. I like to think of them as there's 24 hours in the day. And between each of these bones, you have a layer of cartilage. If you just twiggle your nose, that's cartilage. They're called discs. This right here is a vertebrae. Let me click out. All right, let's see. This will be your back, and the smoother part is on the inside by your guts. Down here, you have a triangular shaped bone that is between your hip bones, and down here, you have your tailbone. So these are called fused vertebrae because there's no discs in between. Okay, let's see. Now I'm going to do my best to scroll up to, there we go. So right now we're looking down the hole that the spinal cord goes in. So I want to actually switch over to this picture. I like this picture because it shows the spinal cord in the actual bone. So the red is the spinal cord. It's protected by the vertebrae. That jelly-looking thing is the disc, and sometimes people get something called a bulging disc. That bulging disc can put pressure on your nerves and can cause intense pain for people. So I wanted to show you this animation because it was the best I could find on bones and its relationship to the actual spinal brain tissue. And then this was kind of interesting, an aerial view. Now I am going to show you a gross image, but I want you to see the entire nervous system outside of someone's body. Okay, so you can see here's the brain, there's the eyeballs, there's your spinal cord all the way down, and look at all of these nerves coming off of it. All of these nerves are called peripheral nerves, and they're all attached here at the end at your fingers and at your toes, and some of them do not, as you can see. They just kind of wrap around your rib cage, etc. So I want to talk about reflexes today, and those are things that use these nerves right here. You have pain signals going in, response signals going out, and the spinal cord is responsible for that reaction or that reflex. So here's your spinal cord. There are your nerves that are going to be directing this whole response. Okay, so take this spinal cord, cut it in half right there. Pick it up with your hand, remember, all imaginary, and look down on it. This is what you're looking at. This is an aerial view, a looking down view of your spinal cord. So this would be the thick spine in the middle, and these would be the branching nerves coming off of it. Okay, so it's called a reflex arc. I will come back to this picture because it forms a half circle. Let's see. the reflex arc. Remember, arcs are half circles, so it's not going to close completely the circuit. Let's see. Let's start. I'm going to use gray. You do not have to use gray, but it works out because the spinal cord is some gray and white matter. So draw this spinal cord and then some tubes coming off like that for the nerves. It's going to look a little bit like a crab. We'll just focus on one side. Okay, so this right here, this is my spinal cord. And these over here, this will be the section on the side where I have my nerves going in and out. So let's go ahead and draw some sort of a pain stimulus. Let's go ahead and put over here a sharp nail. When someone steps on a board, they don't see the sharp nail. They touch it. Oh my gosh, how am I going to draw a hand? X. Oh boy. Just going to go for it. Okay, that's a hand. I'm going to have to label that. Okay, so you have sensory nerves in your hand, and they are going to send the pain signal to the spinal cord. This is going to use something called the sensory neuron. It's got the same machinery as all the other neurons that we've talked about in class. So it's going to have an axon terminal. It's going to be covered in myelin. In fact, the more myelin that your axons have, the faster you are at sending these signals. And they would say, oh, you have a good reflex time. Okay, so you'd have your dendrites here, your cell body, your dendrites, etc. These don't need to be perfect. So we call this the sensory neuron because it's going to send the sensation to the spinal cord. So the sensory neuron. And I'll write down here the sensory neuron sends pain signal. Actually, I should not use the word pain. It just sends a stimulus, a sensory signal. It could be you smell something gross and you want to vomit. You touch something hot, you move your hand. So it's not always pain. So you can use a different word there. It just sends some sort of a stimulus. Sensory neuron sends pain signal to the spinal cord. And then in the spinal cord only, you have a little neuron called an interneuron. This is like in Tinker Toy's little connector piece. So it takes the signal that it just got and it sends it to the correct muscle that's going to be responsible for moving your body part in jeopardy out of the way, or your salivary glands to increase in saliva when you are hungry, preparing you to eat. Okay, so this is step number 1, your sensory neuron. Ouch, 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 or hungry, hungry, hungry. And then you have your interneuron, which is going to connect your sensory stimulus to the correct motor neuron. So the interneuron, if I were just given one word, I would use the word connector. So it is going to connect the sensation, that's a good word, to the correct responding motor neuron. All right. So now you have a response for me. The motor neuron, it's called motor because it's attached to your muscles or your glands. There's going to be some sort of movement. Something's going to happen. Okay, so then you have your axon terminals here. Connector, you have a cell body in there. Myelin, again, I'm not worried about the shape of the neuron as much as how the neurons are communicating with each other. So this right here is your motor neuron. And it received a signal from its temporary boss called the interneuron, because what you're going through is so urgent that you cannot spend time sending that pain signal to the brain. So the motor neuron is connected to a muscle or a gland. So this person's touching a nail on accident. It's going to be the hand muscles that are going to be connected to this motor neuron. But I'm just going to sketch a generalized muscle. It's going to look a little bit like a traditional bicep or something like that. There's a muscle. This is going to be what we call the effector, because it's going to cause the effect. Or it's going to be some sort of a muscle. All right. So in summary, you have a sensory stimulus. You send the signal to the spinal cord. The interneuron connects that sensation to the correct responding motor neuron, and the person will automatically, what it feels like, withdraw their hand. So step number 3 is the motor neuron causes muscle or gland. And when I mean gland, I'm just going to put in parentheses like you're hungry and you salivate, or you're about to vomit and you salivate. Okay, I'm just going to put that in parentheses, salivary gland. Motor neuron causes muscle or gland to respond to stimulus. So over here, I'm just going to write a summary of the steps of the reflex arc. So this is going to be the reflex arc because it's going to be a half circle, information going in, information going out. This is going to be the reflex arc. Step number 1, I'm just going to put pain. Step number 2, sensory neuron. Step number 3, interneuron. Step number 4, motor neuron. Step number 5, it reaches the effector, and you respond to the stimulus.